Going to go ahead, barring, Frizzell being here. And then we can start with the Grape form stuff because John's now here. And is probably waking up in minutes.
I'm trying to get Dave Schwartz online here. He's texting me that he's not able to get in, so.
Is he, I noticed that on my Google Calendar update, because it's old, the link didn't update. It still sends you to the old Grape.
Yeah, it's a Scranton link. It ends in ZZZ09.
No, that's it.
Okay.
Does he need a passcode?
No, I'm sending him the stuff now.
Okay, because I was going to say there's technically a passcode listed, and if you click it through the email or the link, it doesn't ask for it. But
Okay. So,
Gary, did you have a form base you wanted to start with, or did you just want to discuss having a form for the Grape too?
No, I can share my screen and show you what John and I have been working on.
Perfect.
Okay, here goes. Okay, so just be aware. I mean, I'm just trying to help out here. This is just just some ideas thrown up against the wall, see what sticks. I don't know if it's the right format or anything else. We will probably use an online form or something like that. But the goal here is to say, as we go out and recruit people to install Grape 2s, and we think we'll have roughly 30 of them, 30 to 50, depending on the grant, depending what parts are available. We're hoping we get a lot more people interested in having them than we actually have physical units. So we may have to kind of, see where they're located and a few other questionnaires. So, anyhow, I mean, some of the obvious things we would need is people's names, email address, call signs, if any, and also where they actually plan to put the Grape, because that may be physically different where they live. We've got a couple people who volunteer that have summer and winter homes, so they may actually have two. So obviously we get a location and a Maidenhead grid square off of everybody. Pretty straightforward.
Minor point, Gary.
What's that, John?
Minor point, mailing address. You gonna need enough space for 2 lines.
Yeah. I'll worry about the formatting and stuff later. I'm more worried
okay.
about getting the details and the questions. You're right, but you're right about that. So I thought it'd be helpful just to get an idea if people are interested in WWV or CHU, and I'd kind of like to discern if they've actually done their homework. Have they done any listening? Do they have any idea what frequencies they might want to listen to? And the way I put it is, which frequencies can you typically receive for most of the day? Because I don't think any of us with any distance are going to receive any of these stations 24/7.
okay, you want to eliminate the 20 and 25 because Grape 2 will not handle that, nor Grape 1.
Okay, so I'll delete. Easy enough. So the CHU free, I know the 3.330, John, that's a little outside the filter range, but if we leave that on there.
I've probably going to make an entry for the lower receiver to be able to do it. You're probably able to receive it at reduced, but it might be good enough. I don't know yet.
Okay.
Right now I'm
Okay.
planning on doing 5, 10, 15 as the first shot out of the barrel. And then once I get my act together, because the synthesis is tricky. Because there's only 2 PLLs and we got 3 frequencies. So one has to be a multiple of the other. So like 5, it's going to have to be, the 4.999 is going to have to be double that, the 9.998. Stuff like that I'm going to be playing with. So, but that's irrelevant right now.
Gary, may I suggest
Yes,
that you put a note in there that WWV 20 and 25 are not receivable with the Grape 2, but
Or the Grape 1.
well, okay, but this is about the Grape 2. But that interested workers here are welcome to receive those on other equipment.
Well, this this is kind of an application for people who we would want to physically send a Grape 2 and Grape 2 setup to.
Right, so
Well,
that's,
then perhaps just note that Grape 2 cannot receive 20 and 25 megahertz.
which we
Okay.
just did. Yeah,
Well, but say it explicitly.
When it comes to location, how susceptible is the Grape to a big dipole that's going to be running a kilowatt in the morning and in the evenings? Does the Grape need to be shut off? Frequencies
Yep.
are going to be
yeah, you're gonna overload the front end on that.
Yeah, that's one of the questions that's a little bit further down, John. We'll get to that.
Yep.
Good question. Okay, so that helps. I think David's right. People may wonder, well, why not these two? And we should tell them why not. So that's a good point.
Also, 2.5 is not applicable either.
Right, gotcha. Gotcha, okay. I think it's important that we understand, or they understand, the internet connection that would be required to make a Grape 2 valuable for science. So John suggested that we point people toward a wired internet connection. Considering that we're gonna have, what, 10 gigs about a day per or greater of data to be uploaded?
Could I ask you not to pull a Microsoft on us? Express upload speed in megabits per second, since that's the way all
Yeah, it'd be 100
speed
megabits.
should be.
Oh, boy.
Well, the amount of data we're gonna transfer is 10 gigabytes.
Right,
The upload speed I do have in megabits. Is that, if I got that noted correctly here?
No, that's megabytes. And it should be
Okay,
lowercase b and then /s.
okay, how about that? Would that be clear? John? Good point.
that's good.
Okay, is the value of 10 correct? That was my swag yesterday, so.
You're gonna be sitting there for a long time if it's less than that, because we're doing,
Yeah, that's a long time to send that.
but for me, I've only got a 20 megabit upload speed. So yeah, it's gonna be taxing the system for a while.
And do put it in megabits /s or per second, because that's what it is. It's not megabits, it's megabits per second. Thank you.
All right, if you want corrections like that, you need a space between numbers and units.
Yes, you do.
Yes.
And I want it in purple. Just kidding.
It might be noted somewhere that Grape is going to be transferring lots of data, and if you're not on a, if you're on a system, a provider that counts your bits that go on by and charges you accordingly, you might want to think about the cost of that.
That's a good point. Are there any of those systems left? I don't.
This knocks out everybody who has a DSL, because upload speeds are usually about 1.5 megabits.
Yeah,
Although I'm running DSL and I'm getting 20, but mine's are kind of it's a dual DSL. the
Yeah,
way-
you got a good system there. My upload is about 1.5 megabit.
So one of the things we'll have to figure out, once we get the, I call it technical requirements figured out, is decide what do we want to put in kind of like a brochure or a handout? Because one of my goals would be to have this figured out by the Hamvention.
Yeah,
So as all of us who are going to be in the HamSCI booth, if somebody wants to talk to us about the Grape 2, we can hand them something. If they want to talk to us about the QSO party, we can hand them something. So we've got 48 days, I guess. But so at some point, yeah, we're gonna need to figure out what are we gonna do to market it, and versus what do we need to collect technically. So in this document probably crosses both of those up. But these are good notes.
I agree.
Okay. So we wanted to emphasize the wired internet connection, and I wasn't sure if if somebody had this thing out in their barn, in their backyard in Wyoming somewhere, can they bring the hard drive in and do a manual transfer every day or every couple of days, or am I off base on that?
The problem is, well, for one thing, the Grape 2 comes with a solid state drive, a 1 terabyte solid state drive. So it has the drive already. The problem is you're continuously writing to it, so you can't disconnect it because you shut the data collection down. So any transfer of data while you're actively collecting data is going to have to be via Ethernet. That's your only choice.
Okay, so this
you
doesn't make
could-
any sense. I'll just get rid of this.
Yeah.
So I will just have to emphasize that that's required somewhere. Okay,
Now the power source for the Grape 2 is 12 volts. I did that specifically so it could be done off of a backup permanently. Whether we provide the wall wart that handles 12 volts or they provide a power supply with backup, it's up to them. I haven't crossed that bridge yet.
Yeah. I've got a big box of old wall warts, but
Yeah, they have to
I'm
be
sure
on amps to handle this, so.
Is it gonna be like the Rig Pi where you have to have at least a 2 amp,
Right.
2.5 amp supply?
yeah, you might want to say that if we're not supplying it.
Well,
Yeah.
that's a bridge I haven't crossed yet. We probably will be, but I'm not there yet. Problem is, I just had to rip out the switch mode power supply that runs the whole thing because of the solid state drive. So I'm still in the process of figuring that all out.
my gut feeling is we would want to supply a wall wart, whether they used it or not, just because we got one that's, 1, RF quiet enough, and 2, has enough current capacity, because we don't
Right.
need people plugging these in and having issues. So they're cheap, give it to them, and if they don't use it, and they want to use 13.8 volts, like I said, one or the other has to be available, so.
Yeah, I agree. That's a good idea, Gary.
So now one that's a little bit sticky, maybe not. As I say, every receiver requires an antenna. We don't need an exotic antenna. A simple random wire will work fine where reception is good. While a resonant dipole, perhaps broadside to the station of interest, might be beneficial in some locations. I mean, it's obviously a huge variable. If
Yeah.
somebody thinks they've got a lot of antennas, let's ask them and see what they've got.
Yeah, again, since we're receiving, it does not have to be resonant. It needs, if it's a wire antenna and it's horizontal, the broadside needs to be facing WWV or CHU if we get that going.
Would a resonant dipole help just a little? I would say maybe a little bit with RF filtering. Just we're kind of band limiting it may not be significant, but.
Well, the resonance just makes it more receivable at that frequency. And if there's interference on it, again, you can make the argument that it makes it worse. But for just receiving, a piece of wire is good long enough as long as it's long enough. I mean, you can't use a 6-inch stub, but I'm thinking for us providing the antenna, that we're going to provide wire antennas, probably with the 9-to-1 balun that uses the SMA connector into the receiver. So just to keep costs down. But
Yeah, exactly. So I took your suggestion from yesterday and said, if you want it to be delivered, it's a random wire. I'm just curious, how much room do you have?
yeah,
And about how high off the ground would it be? Just because we may get more applications than we can service, and we may have to sort them out, and maybe this
Right.
is the criteria,
ideally you'd like to be, I'm thinking 20 to 30 feet up. I mean, if you put one at 6 feet up, it's not going to work that well.
I have an inverted V. I'm living in a Victorian house with a full attic,
Okay,
and the apex of the V is out the attic window down to the ground. One leg is shorter than the other,
okay,
but that's the windows may be 30 feet up.
that sounds perfect. Can I come over and use it?
Can I jump in here for a minute?
Sure.
Hey, John. Hi, everyone. I'm looking at the bandwidth requirements. I think we are overestimating the required bandwidth for this project, and maybe want to take this offline to discuss it. But I don't think 10 gigabytes per day is anywhere, I think that's way more than is actually required.
Oh, that's actually the file I generated after creating 1 day's data,
Well, that's why I think we need to look at that file because
but it's not compressed. So compressed, we're going to get it down to 5.
It's not just not compressed. I don't think we don't need to be storing and sending, 5 or 10 kilohertz of bandwidth per channel. I think we need to be storing on the order of 5 to 20 hertz per channel. And if you do 5 to 20 hertz per channel, you are reducing the bandwidth requirement by orders of magnitude.
I do not have the horsepower to do that on the fly. That's why I'm having trouble. The Raspberry Pi cannot do that.
That's why perhaps we can talk about that offline.
Okay. But this is part of the problem. It's like I say, this was intended for the Tangerine, and since the Tangerine isn't going to happen,
yeah,
let's
chat about this offline, John.
Okay.
Okay, so if they want us to supply an antenna, if that's gonna be a possibility, at least have some idea of how they're gonna install it. I mean, yeah, indoors, obviously, George, you're right, would be fine too, in a lot of cases.
Just
I was
out of
thinking height above-
curiosity,
Go ahead.
I've got a 10-foot tower, and I have got plans to take an old unused marine SSB antenna that's 21 feet and put it up maybe with a tuner. It would be a vertical setup. That shouldn't have any obstacles to receiving, would it?
That should work.
Okay, well, it's an antenna that's been waiting to find a use, and now I've got it.
Yeah, but if you're receiving with it, I would eliminate the tuner,
Absolutely.
Okay, just
because that's
go
just an
ahead and just make it a
attenuation.
random.
And besides, you got 3 frequencies you want to receive.
Right.
Don't need a tuner.
Yeah, you don't want a tuner.
Oh, that'd be even easier then.
Yep. Simple is better.
So the last section is kind of what I kind of thought was the trickiest, just to get people thinking a little bit, just as you suggested earlier, John, do you have a high power that may cause descents? We've had in the previous designs of the Grape 1 some issues with lightning, and I would like people hopefully at least to do a little bit of listening before they ask for one of these receivers to see if they've got a electric fencer next door or a marijuana grow site or something that's wiping out the bands before. So this is kind of a touchy thing, but I thought it was worth asking the questions anyhow.
Yeah, if you're within 100 feet of something putting out a kilowatt, you've completely desensed the front end, and you're probably slamming the input protection diodes pretty hard. So that's probably going to be an issue.
Okay, so with the radio turned off, is that an issue, or was the Grape 2 turned off?
The Grape 2 would need to be disconnected. The antenna needs to be disconnected.
Okay, just
You can leave it running. Yeah, it won't be receiving any data, but yeah, you don't want the antenna inputs hooked up.
Okay, so you don't have to power it down and disconnect the antenna, just disconnecting the antenna. The SMA that's going into the Grape is all the
Right.
seed.
Right.
Do we also want to give them a spot down here to not just comment, but specifically maybe ask questions of us, just so that we can make sure that they are all clear on everything before wanting one of these?
Well, you got to think about the time to answer the questions. Who's going to do that?
There. But I feel like it's more of if the questions don't, the questions will almost give us some amount of information as well, or they could put it in, you could put it in here as well if you have any questions.
Or email questions too.
Yeah.
That might be better.
Yeah.
Yeah, thought I had that in one of the versions I was working on last night. Oh yeah, it's at the
Oh,
very
yeah,
top, but maybe it needs to be repeated at the bottom, so. But
Yeah,
anyhow, I'm not so much, again, worried about the format, as worried about what questions everybody thinks
yeah,
are
the content
important or,
is the issue.
yeah, yeah, at this point. So. So I'm happy. I mean, I think we've got a good start here. I can add a couple of these things and just, I want everybody to be aware that this document at least exists and we got something we can build off of. And again, focusing toward the hamvention, so. That's that. I'm done.
Wish I could say that.
I think that's great. Thank you for making that.
Thank you so much, Gary.
That's a huge step forward.
Let's see. So, John, did you want to do a Grape update today at all? 'Cause if not,
Yeah, it turns out that Bob had told me he had the transfer working to the Grape from the Pico to the Raspberry Pi. Well, he didn't tell me it was just spitting into a terminal window, not going into a file. So I haven't really cleared that hurdle yet. Right now I'm fighting tool sets, trying to get stuff to compile for the Pico. Once I get that going, I'll be able to take A to D readings off the RF board. Once that's done, then I can order the RF board and get that rolling. And then we can finalize the architecture and get a board made for the base system that the RF deck plugs onto. So that's where I'm at. And in my free time, I've been remodeling the upstairs of my house. So
You're busy.
Yeah, I'm painting my basement so we can trade off, trade labor.
you can have the door frames. They're all yours, man. Oh, those are the butt to put in. And I got 6 of them to do. Well, I'm pretty well almost done with it, but close.
Have you picked a PC board manufacturer?
Yeah, probably is going to be either PCB Way or JLC PCB.
I was going to suggest them.
Yeah, I've had really good luck with them.
They are really top notch and you can get stuff if you do the DHL Express, you can get stuff in 5 days.
Yeah, the DHL is the only way to go because otherwise it goes via post and that usually ends up being 2 or 3 weeks. And for boards that are more than 4 or 5 square inches, they're cheaper. If they're smaller than that, OSH Park on a fast turn, you can get them in 7 days. On a 2-layer
Well,
board.
they're doing 4, if you're 100 millimeters, which is 4-inch square. The first one's $2 and then they're $4 a piece after that.
Yeah, JLP PCB, I ended up for one order, I had the order was $70 for 50 boards and the shipping was $85. So yeah. And it was Enid gold plating as well. So they do good work. Been pleased
Well,
with
I've got 2 coming. I just got notified about it and dadgone shipping is $30 for 2 4x4 boards.
that sounds about right. Yeah. Back to you, Rachel.
okay, I was gonna just say any other questions for John. If not, we have some plots from 88Y. Kasdan,
Yeah, let's see, do I have screen share?
Frizzell, did you have something?
I was wondering, you know, I'm planning on talking to John later, but perhaps John and I could take this time to go to a breakout room and we could chat a little bit. If that makes sense.
Yeah, actually, Nathaniel, hang on for just a second. Take a look at these plots.
Okay.
All right. 10 megahertz Dopplers here in Cleveland. This is a fairly normal looking day, March 18th. What I want to show off is changes that took place during a coronal mass ejection, also around the solstice. So the next day, yeah, isn't too much different, except it has some spikes. The day after that starts to have an unusual feature. Let me get a laser lighter. Let's see. Okay, notice this dead flat spot Like you would think that WWV could actually be used as a laboratory standard here. It's amazing. The ionosphere must have been blasted into submission from the outside. And over the next several days, there are more of those. Here is this remarkable flat spot. And the next day has some more.
Wow.
Yeah. So others, take a look at yours from these days. See if you have some of this also. Here's a bit at a different time. Even though the ionosphere looks unsettled about like it usually is. And then this was the day that a huge coronal mass ejection hit Earth. My 25 megahertz tracings from that day are completely blank. There was no signal at all. But I don't have any way to interpret this. Nathaniel, maybe you want to weigh in. But I thought this was really pretty amazing. I think it continues for a couple of days. Yeah. Here's this one. This was the second major day of the CME Earth strike. And then it starts to taper off, and I began getting my 25 megahertz signal back. And there's this one, which I can't associate with the CME. And then we're back to current time. This
Go
is
back one step, David. Notice you had, okay, go back 2 days.
one moment. There.
Yeah.
And this prang.
Yeah, that at hour 21, that is a huge like snap.
So I don't have intelligent things to say about it. I just want to point it out and ask others to take a look at their tracings.
If you go ahead a day, 2 days and look at the black line standard slope that's typical for 10 megahertz. Yeah, see how from 12 hours to 24, it's got the black line has a general downward trend.
Yeah, this is yesterday UTC. This is much more typical of traces that I get here.
I have started doing 15 megahertz with Grape version 1.1, and 115 megahertz also does that.
So Nathaniel, anything to say about those?
Yeah, so I think that's very interesting. I think your idea of comparing it with other people's observations is a really good idea. I think you should also, there's a parameter called the SimH index, and the SimH is a measure of the geomagnetic storm impact in the magnetosphere. And from that, you're able to tell exactly what phase of the geomagnetic storm you're in. So I think plotting that along with what you see might be useful, as well as looking at some other ionospheric instruments, either SuperDARN or ionosondes, and seeing how they all compare. So I think, whenever you see like an unusually flat line like that, you have to wonder, is it an instrumental thing or is it geophysical? And if you're able to, corroborate what you're seeing with both other grapes and some of these other ionospheric instruments, and also with the SimH index, you're able to make a better case that what you're seeing is geophysical and perhaps get some sort of understanding as to why it's doing that.
All right, well, John, you're nearby. If you could take a look at your 10 megahertz ones.
Yeah, I'll take a look at that.
All right, anyway, that's what I wanted. Thanks.
I'm
Rick.
looking at the Northeast groups plots of that period and don't see the super flat line.
I didn't see any super flats in that time. I've seen them before, but my 324 was markedly different from yours. Mine 324 is about the wildest there's been.
324.
As I said, my 25 megahertz ones have been disturbed too. And they're on a completely different data collection mechanism than these.
This is Dave in Colorado. I'll try to get a hold of Darren, who is the FTP repository person for our website. Right now, we've got all of the graphs available, but you've got to be able to log into the computer. We were concerned about some security issues and things. So, and that's his job. So that's why he's sort of put it at a place where it's not open access to everybody. But I believe Christina has access and Nathaniel has access to all of those files in the Node 37 directory that we have on WWV website.
No, for 324 up here in the Northeast, we don't see any strange flatness.
David and John, you should be able to look at those files too for any of those dates.
Okay.
All of the grapes.
Thanks.
Actually, Bill Blackwell, AB1XB, has been compiling plots from all the stations in the Northeast, plus all this, a lot of stations across the country.
Hmm.
And he showed some of those to Christina at the workshop, and she was quite interested.
Yeah, actually, Stan and Bob did, but these are the plots we produce daily, and she's on the mailing list now, getting our plots, and they show the Northeast stations. There's about 9 nodes here that we plot together, and I'm looking at them now and didn't see the very flat, curves that you saw, David. But we also plot a couple of other stations across the country that are working with us. And
Could you put up that plot for what was that?
yeah, can I share that? Is it okay?
Yeah, if you
Yep.
can do it.
All right, let me find it on my. Okay. Let's see. So here's. Let me just see what I'm looking at here. I got to move some things around on the screen so I can
That's
navigate.
3.
So this is the full group, all the nodes that we're monitoring, and we have subsets. This is on, sorry, the 18th, 17th, going the wrong way.
There we go. There's 19th.
There's the 19th. There's 8 of them each. So they're separated into Doppler shift curves and strength, signal strength curves. So here's the 20th. This is the so yeah, I see that flatness right here from my Florida station right here.
Hmm.
Around 1800, 1900. Then the British Columbia looks, this one is purple here.
Yeah.
It's also flat. I have to scroll in and see. Yeah, he's fairly flat in here. Sorry, there's so many. We have, okay, these are signal strengths. And then this is just the Northeast subset. And you can see there's nothing in here that is really, I would call flat.
Right.
This is again for the 20th. Now we're gonna go up to
Ooh, British
21st.
Columbia on that one is flat,
Yeah,
as well as the darker brown one. Not sure.
yeah,
that's-
actually that's just signal off the air. I think that's one of Bob's
Oh,
grapes.
well, okay.
Yeah, he's off the air here.
Oh, okay.
Let's get through the 21st, go to the 22nd.
So is there any way to mark the graph or mark the data that it is off the air?
Sorry, I'm getting a phone call here. I apologize. There may be. And that's a general question. How do we indicate when we've disconnected the station so that you ignore the data? So here's, let's see, Northeast. I'm sorry these are so disorganized. I'm trying to get up to where David was on the 24th. This is still the 22nd, so you can see British Columbia is pretty flat in there. 23rd, wild stuff going on in BC.
That's a
And-
trick.
and
Wow.
but only BC.
And then it flattens out at the end.
Yeah,
Wow.
Is that British Columbia?
Yeah.
Aurora,
David,
Aurora.
That could
and
be.
that's a signal strength for the 23rd.
Yeah, there's some definitely stuff going on there.
That's northeast, so we all saw a big peak up in New England there, but none of the flatness. Anyway, I'll stop sharing and let
No,
them.
that was good.
Can we see the 24th?
Oh, yeah.
That's the day I really had the disturbance.
Okay. All right. Yeah,
Yeah,
that's everybody.
especially
Yeah.
at 1600. Wow.
I don't know what was going on, but I'd love to know.
Or maybe you don't want to know.
Nathaniel, I used your plot probably a year ago that correlated this with solar flares. But I'd like to get that going again with using your software so we can see,
Yeah.
just for curiosity.
This sort of behavior, I think, is unlikely to be solar flares because solar flares are usually just, there's a sudden flash in the Doppler shift, sudden positive flash, everything would move together and you'd see a dropout in the power, the received power. Okay, what we're seeing here, I would start looking at like geomagnetic disturbances. So again, if there's this parameter called SimH, that is used to tell you where you are in a geomagnetic storm. The reason I'm not saying to use, so you're probably familiar with the KP parameter.
Yeah.
KP is only given every 3 hours, and it's this quasi-logarithmic scale. DST can give you the same information, but it can give it to you or SimH, it can give it to you in a 1 minute cadence. And you can actually see different phases of the storm where you have something called the sudden storm commencement, and then you have the main phase and then the recovery. So you really want to be using that parameter and plot that with this to help give you some idea of what might actually be happening.
Can you send me some information about how to get that data? Or
Sure.
is it easy to?
So if I can, I'm going to share my screen for a second.
Yeah.
Yeah. So you can, let's see, screen 2. All right, so I write about this in my September storms paper using RBN and WhisperNet data. So I can put this link in the chat here.
Great.
And so I think figure 5, 4 and 5 might be the best ones to look at for this particular thing. Download the.
Okay.
So here's figure 5, and the top 2 panels. This top panel is the one you're probably most interested in. The black line you see here is the SimH index, and the green and red are the KP index. So you can, and this is going from September 6th, 2017 up through September 12th, 2017. So this is a 6-day period. What you can see here is that KP is relatively low at the beginning here, and then it suddenly jumps up. So here's where you have the big geomagnetic storm in response to the coronal mass ejection. In the black line here, this is a SimH measurement, which is actually comes from ground magnetometers around the equator. Right at the beginning of the storm, you see a positive excursion in SimH right there. You see how it just jumps up a little bit right there?
Yep.
That is what we call the sudden storm commencement, and that's the result of the coronal mass ejection pushing the magnetopause closer to Earth. And then those magnetometers are now sensing an increase in the magnetopause current just because it's closer to Earth.
Okay,
Okay. Then you see the sudden drop off in the SimH index right here. This is what we call the main phase of the storm. During this part of the storm, you're seeing all of these electrons enter, you're seeing a ring current enhancement. So this is a current system, say like 3 Earth radii away from the Earth, 3 to 6 Earth radii away from the Earth. And that is corresponding, that gets enhanced during a geomagnetic storm. The direction of that ring current is such that it's opposite to the magnetopause current. So it causes a depression in the SimH rather than an increase. So the more negative SimH becomes, the bigger the storm. And then you can see as the ring current dissipates, we go into the recovery phase of the storm. And so it's getting a little less. And then you see another drop off in SimH. So this is telling you that something else happened out in the magnetosphere, causing, this is like a second part of the storm, and you can see KP jump up again.
yeah,
And then you can see it takes days for things to recover back to normal.
wow.
So what you really want to be looking at is this SimH parameter, which you can see gives you a lot more information about what's going on than just the KP.
Yeah, a lot more detail.
Yeah, and then along with that, you can see I also plot, this is the solar flare information. I plot
Yeah,
that down here.
That's what I
So-
was plotting before, and I don't
Right.
see any correlation there.
Exactly. So yeah, so you probably want to be looking at something like this.
Okay,
Okay, so it's good to look at both of these things at the same time. So I can point you to a couple more resources. First of all, to get the most recent SimH data, you want to go to the Kyoto World Data Center. And okay, you can actually look up, there's something called DST. So DST and SimH are essentially the same thing, except DST you only get in a 1 hour index, but SimH you can get in like 1 minute. But it's pretty much this present month. This gives you the real-time DST for what's going on in the world. So you can see a couple days ago, here was the storm. Here, I'll put this link in the chat too.
thanks.
Yeah, you're welcome. So this one, so the problem is, where do you get the latest information for the last few days? Because most of you are seeing things and you're coming up to us and saying, oh, we just saw this. What happened? What can I compare it to? And it turns out that the pipeline for getting you've got to kind of go all over the place to get the data you need to look at for just the next few days. Whereas if you're looking at events that happened, 6 months or a year ago, there's a database where they give you everything all in one place and it's nice and easy to get to.
Right, but that's more archival, right? It's not up.
Right, more archival. Yeah, so the Kyoto World Data Center is probably the best place to get the latest DST. If you want to see what's just happening in the last couple of days, NOAA SWPC Space Weather Prediction Center, you can also get this information off of here.
Okay,
Let's see, so if you click products and data, observations,
wow.
let's see, space weather overview, let's try that one. So here they have solar X-ray flux, geomagnetic activity, or solar X-ray flux, solar proton flux, geomagnetic activity. They're still just giving it to you in terms of KP. So if anyone finds a better website for getting this DST and SimH in real time or near real time, let us know, because I still haven't figured out a really good site for that. If you're looking for things on a more archival basis, there's something called NASA Omni, which kind of gets everything all in one place for you if the website's running. So if the Omni website's not running, there's also something called NASA CDA Web, which stands for Coordinated Data Analysis. And so you can, why am I having, Maybe NASA's just having some trouble this morning.
I hope so.
Well, for both, I mean,
Yeah.
I'll put the link in the chat. See if anyone else can get onto this.
All right.
See if you can access this website, because
I couldn't
this
get to the
is,
one.
what's that?
I said I couldn't get to the first one. I don't know about the second. So it might be a NASA
Yeah.
problem.
Oh yeah,
No,
it
I'm
might
not-
be an
I'm not getting it
But-
either.
Okay, so when it starts working again, maybe on a future telecon, I can show you where you get the same information for archival dates. And they have that, this OmniWeb does a really nice job of getting you all the information you need in a format that is easy to compare to the observations, to the
Fantastic.
Grape observation.
All right, great. Super. Thank you, Nathaniel.
And let me point out one more paper that I really like. My colleague Evan Thomas did a paper using GPS TEC and looking at storms. And I think he does a really nice job characterizing that. So I cite his paper in my paper. Thomas et al. 2016. So here, I'll put this one in the chat too. So what Evan does is he does a really nice job of explaining what signatures you see in SimH/DST during a geomagnetic storm. And then he also does a really nice job showing what the total electron content response is for different phases of the storm on a global scale. And that's something that I don't think is really appreciated by people who are just looking at KP and trying to understand what's going on. So if you look at his figure 1, you can see he's plotting SimH here for 139 different storms. And he's done what's called a superposed epoch analysis, which is kind of what you're doing. But basically he keys all of these storms off by the sudden storm commencement. So this black line is the average of all of them.
Okay.
The thick black line is the average. The thin black line is the like 75% quartile, and that's the one above, and the one below is the minus, the 25% quartile. So you're getting what an average storm looks like in SimH. And so you can see on average, you get this short sudden storm commencement as the magnetopause current gets pushed closer to Earth. Then you get the development of the ring current, which creates the depression in the DST index or SimH index. And then you get the recovery over multiple days. So you see usually here on average, it takes about 3 days for things to more or less get back to where they were. They're still kind of on the bottom side of things there. But then he goes on to show these other plots down here. This is what's really nice. So this is total electron content measured by GPS TEC receivers. This is relative total electron content. So if you see reds, that means you're seeing more ionization than usual. If you're seeing blues, you see less ionization than usual. And then this is again a superposed average response to these 139 storms, and it's all keyed off relative to storm onset. And so you can see right when the storm starts at 0 hours, you're seeing across the entire globe, this is looking down on the northern hemisphere, organized in magnetic longitude and latitude. You can see across the entire globe, you actually see an increase in total electron content. And then for the first few hours of the storm, you actually do continue to see an increase in total electron content. So this is what we call the positive phase of the storm. So so at the beginning of a storm, when KP first increases, you might actually see enhanced propagation at higher frequencies. But then you get to what's called the negative part of the storm. Now you start to see these blues come in. And it's interesting, it doesn't happen across the entire globe all at once. It happens over in like Here it's starting on the dawn sector, and then gradually the blues take over for the majority of the storm, where you would, meaning you see less electron density in the ionosphere, which would correspond to worse propagation on higher frequencies, which is why you need to go down to lower frequencies. And you can see that.
Would that coincide with a Doppler shift that we can see that's positive?
It's that relationship's going to be complicated. So that's where probably some of the research would be. Because this is just showing, on average, this large scale perturbation of the ionosphere over hours. But when you're looking at these Doppler shifts, you're looking at changes on the order of, say, minutes.
Yeah.
And so even though this is all averaged and smooth, so what's going on within the order of minutes on any one particular day, that would be, you'd have to look somewhere else for that information.
Yep.
Like your grapes. But this gives you some sort of idea of the bigger morphology that's going on.
Fantastic.
That you kind of have to put yourself into. So yeah, I recommend reading my paper. I also really recommend reading Evan's paper and the references therein, because that kind of gives you a better understanding of what a geomagnetic and an ionospheric storm actually is.
Wow, fantastic. Thank you.
Sure.
Much appreciated.
You're welcome.
Anybody want to look at more? Did I get up to 324 or are we done with that topic? Or I'll go away then.
I think what you're doing is great. I think the questions you're asking, what's going on and what to compare it with are a really good idea. And I think the only way we're actually going to be able to understand what the grapes are seeing is by comparing it with observations from other instruments and understanding, what is known in these current papers. And hopefully there's a lot of things that we can explain with it, but then it's a little bit that we can't explain that we have to really scratch our heads. And that's, actually the most interesting part.
Yep.
With that, I have to class.
Before you go, Rachel, did
Yes.
you say you were asked to be a convener for an eclipse session at Cedar?
Right, they still need to submit. So I wouldn't say
So
yet. They haven't.
Gareth was interested in that, so I guess we were wondering who else are your co-conveners?
I'll pull up the email now. It got forwarded to me by Christina. Sarav is doing it, and Michael Hardinger.
Michael Hartinger, who's the other person?
Sarav Ariel. I'm probably mispronouncing his name.
I don't know that person, or at least it's not ringing a bell. I know Mike Hartinger well, so
Yeah, well, he presented, but
the other thing I will point out to people that will be of interest on the group. So what we're talking about is there is a conference that's coming up this June 25th through 30th in San Diego. It's called the NSF Cedar Conference, where Cedar stands for Coupling of Energetic Dynamics in Atmospheric Regions. So this is kind of the conference to go to if you are interested in ionospheric physics and that sort of thing. We don't have funding, the same way we had SSBI workshop to pretty much send like every single person to this conference. We do have funding to send, the people who are actually like on the grants to this conference. But if you're interested in going, you can certainly register and go. If you are interested in going and you are actively participating in collecting data and you need some financial help, you can email me and I can probably provide some sort of subsidy or something like that. Also, if you want to go, I can also appeal to the organizers to either provide reduced or waived registration for citizen scientists, which they have been amenable to in the past. So I know Rachel's planning on going to this, Garrett's going, I'm going, Bill's probably going. Quite a few of us will be going. So if you're interested in hanging out with the professional science community, this is the place to be this summer. Are you saying something, Garrett?
How about now? Can you hear me?
Yes.
Yeah, perfect. Sorry. Just add one thing for Rachel. I was just really concerned that Eclipse would be missed, but I'm glad Mike and you're picking it up and making sure that there's an Eclipse session there. Just ask for AV such that you can broadcast it over Zoom or something to allow citizen scientists to participate. I know the CDAR organizers say that they're not going to be able to do that. But I'm taking the tack of just telling them, tough, I want you to do it, or I want you to help us do it. So I'm helping submit a session. That's a different session that we're doing that. We're just explicitly asking for that support. And we're trying to force them so that citizen sciences can participate at least virtually. So.
Right. Well, I think Saurav is the one sending in the session proposal. So I'll pass that along, but I do have a class. So
yeah.
All right. Thank you, Rachel.
Okay, I'm heading back to my painting project. Everyone have a great day, and hopefully we'll see a lot of you at 4 o'clock in the SCQP call today.
Thank you, Gary.
John, I'll be around this afternoon.
How do I make sure I'm on that list to get that form when you finished putting it together?
But for the Grape 2s,
Yes.
I've got a spreadsheet, John. I'll drop your name into it, and I've got Bill on there already and a few other people. So I'll get you on the pre-list.
Okay, thank you.
Sure.
Thanks, Gary.
73.
73.
Everybody.
Just one note for John John is gone. John is still there. And Nathaniel, I have an idea for how we might want to talk about a way to post-process the Grape data to get the size down. When if you're going to have an offsite or a side discussion on that. So.
Yeah. Do you